Okay, so first we want to know where did the recursive and explicit formula for the arithmetic and geometric came from? Like these shapes, like how did they like conclude them? So the recursive, we know that it's u1. The formula is u1 equals to, and un plus 1 equals to a un plus d. Now, where did this exact formula come from? So first, let's take a look at the nature of the arithmetic sequence. So it's basically a and a plus d, the common difference added to the term that's before it. So it's also a plus d, which is the term before it plus d, or plus 2d, a plus 3d, and so on. So basically, the recursive one is very simple. We just take the first term and we keep adding d, d, d. So if we want any nth term, we take like nth term here, it's n plus 1. We take the term before it and add d to it, which is basically the common difference. Now u1 equals a is basically where to start. So this is like kind of the starting position. Now for the explicit one, we know that u1 equals a, u2 equals a plus d, u3 equals to a plus 2d, u4 equals to a plus 3d, and so on, okay? So if you notice something here, we have u of 2 equals plus 1d, of 4 plus 3d. So if we want to get to a certain nth term, it's basically the first term plus the number of terms multiplied by the common difference. Now the number of terms when you want to go to the nth term is basically n plus 1. A is the first one. Okay? But this itself came from a more general rule, which is un equals to ur plus n minus r times d. So when you want any nth position, it's if you start from the rth position, you basically just add the number of steps that you went multiplied by the common difference. This is how we got this formula for it. Okay, and so for the geometric one, we first know that this is the shape of the sequence times a times q, okay, times a times q times q. So it's basically the term that's before it times the common ratio q, okay, so and so on. So first, it's basically like kind of the same idea there. So if we have the starting position a1, okay, or sorry, a, which is basically n1, u1, okay, and each time we increase our steps by multiplying by q. So it's basically u1 equals a, and un plus 1 equals the term before it times q, un times q, as you saw there. So this is the recursive form, and for the explicit one, it's pretty much like the same. Okay, we have the starting position u1, and each one is multiplied by the one that's before it. Okay, so if we want the nth term, okay, and if you notice here we have u4, it's a times q to the power of 3, which is one step less than it. Okay, so if we want the nth term, if we want un, it's basically equal to the first one multiplied by the number by the value of q times the number of the steps, okay, raised to the power of these steps. So if we have un, it's obviously n minus 1 steps, because we are excluding the first one, okay. And you may ask, why are we excluding the first one? Because this is the first step, so the rest of the steps is basically n minus 1. So we basically did a times q, then a times q squared, then a times q cubed, blah blah blah, n minus 1 times. Okay, and this is also a specific formula, sorry, a specific rule of a more general formula, which is un equals to ur times q n minus r, which is exactly the same idea as the one that's before it. Okay, it's when if we took ur as our like if you want to say starting reference term or position, okay, we simply multiplied by the number of steps or the number of times that we applied q to it. Okay, so we applied, let's say, q to it 10 times. Okay, like if un was 20 and ur equals 10, the number of steps between them is 10, so we multiplied by q 10 times, so it's q to the power of 10. Okay, this is the main rule and this is how we got it.